I'm Kirsten, and you've learned all about PCR, and now we're going to learn about something called an ELISA test. It stands for Enzyme-Linked Immunosorbent Assay. So we're basically replicating what happens in your body, but we're doing it in the lab. When the parasite gets into your body, your immune system mounts a defense to that with antibodies. And so we put the antigen in the plate, and then we put blood samples in the plate, and then if the blood sample has those antibodies present, then the plate will turn a different color. So this is a way that we're developing so that we can maybe, hopefully someday, not have to do lumbar punctures, but actually just do a blood test. The first thing that goes in the plate is the antigen, and then we incubate that for a little while. Then the sample goes on top of that, and that's already happened too. That's a couple hours of incubation time that we're skipping. In the final steps, we introduce a reagent that will actually show us the reaction of antibodies with antigen if it's present. So theoretically, people with antibodies will have their samples turn a different color, and people without the antibodies will not. If a sample doesn't react, it can be also because it's an old infection or an old encounter, shall we say. It's not always a full-blown disease kind of scenario. So for a test like this, some diseases and parasites share antigens. So it's important for us to find out whether what we're looking for is actually there, or if we're finding something else with a similar antigen or the same antigen. So these tests take a little while to develop, but we're hopeful that this will work out really well for us. Let's take the plate over to the reader. So this is our plate washer. This saves us a lot of time doing all that pipetting. I just did a little bit, but this does a lot. So this saves us a lot of time preparing the plate. Afterwards, we read the plate. Okay, so our washer has finished washing. This is actually a 2-day process where first of all we start by blocking the plate with the antigen and leaving it overnight. That allows the antigen to seal up to the bottom of the plate. Then the following day, we have to block that antigen reaction. So we take something called BSA, or we can also use powdered milk. It's a protein reaction. So that blocks the antigen from doing any more binding to the plate. We want it to be at a certain level to detect what we're looking for. So on the second day, today, we added our samples, and then we allowed it to incubate for a little while. Then we added a secondary antibody, and that stops the reaction between the blood and the antigen. And then we add a few reagents, which you saw me doing. The plate washer does all the hard pipetting work for us. And then we're left with a plate that shows us our samples. We do put this into a reader to quantify the reaction, but you can actually see with the naked eye. This is our positive control. These are people that have been diagnosed with rat lungworm in this 3 wells and this 3 wells. Those are our positive controls. Our negative controls are these clearish wells right here. So as you can see, they did not react. Then throughout the plate, you see varying degrees of yellow. So some people reacted as much as or more than our positive controls, and many people did not. So this gives us an idea based on what people have told us about their medical history and their diagnosis status. We're able to draw some correlations between infections and how much their blood sample responds. So in an older, say, infection where someone was infected 15 years ago or something like that, you might get a lower reaction or none at all. In a new situation, you may see more of this kind of color reaction developing. These particular people were diagnosed at Hilo Medical Center in 2014. And that's when this blood sample was drawn. So we're hoping to be able to follow people's infections once they've been diagnosed and get some more evidence that this test may help us decide how far along somebody is in their infection. So it takes a lot of time and research to make sure that this test is actually showing us what we think it's showing us. The antigens that the parasites have or that diseases have can often be shared. So some diseases have the same antigens, and then you think you're testing for one thing and you actually find out you're seeing a different disease or parasite. So we need to do a lot of work to make sure that's not happening here. Okay, so the ELISA test is used to detect many diseases like AIDS and cancer in some cases, and hopefully soon, rat lungworm.